In this video lecture, let's learn about four important parameters in mechanics: speed, velocity, acceleration, and mass. Let's start with speed. Speed is the rate of change of distance. What do we mean by that? If you start with an object being at its source on this location, and it travels from this far and then moves to this location, we could say at time t1, which is the beginning, that the object was at distance d1 from its source, and in this particular scenario d1 happens to be 0 distance from its source. And then at time t2 the object has moved to this location, which means it's at distance d2 from its source. In this situation, we say the speed of the object, which is represented by s, is the ratio of the change in the distance, which is d2 minus d1, over the change in time, which is t2 minus t1. And this is the rate of change of distance. And if you plug in numbers thinking d2 was to be 60 meters, and let's say t1 was 10 a.m. and t2 is 10:01 a.m., which is basically 1 minute later, what we get here is 60 meters is the difference between the distance, and 60 seconds is the difference between the time, resulting in 1 meter per second speed. And this speed parameter does not mention anything about a direction. And if you add direction to speed, rate of change of distance with direction refers to velocity. What do I mean by that? If I told you that I am at San Jose at 10 o'clock in the morning and I travel 100 miles per hour for 1 hour, without telling you which direction I am traveling in, you are not going to be able to tell me where I will be at 11 a.m. But instead, if I said I am traveling at 100 miles per hour for 1 hour and I am driving south, then you will be able to make a prediction as to where I will be at 11 a.m. So velocity includes direction, so that the magnitude of velocity is the same as speed. So velocity is also calculated as the rate of change of distance, except that when we talk about velocity, we also have to include the direction in which this change is happening. So that's what makes velocity a vector quantity. Now we have speed and velocity. The next parameter, acceleration, is the rate of change of velocity. This is where using the formal t1 and t2 helps us. So if you again start with an object that's moving at 10 meters per second at t1, and it keeps moving, and by the time it's at this location, it's actually moving at 20 meters per second at time t2, right? So this is time t1 and this is at time t2. So the velocity of the object itself has changed over time. So when we say acceleration is rate of change of velocity, acceleration is represented by a, we are saying that acceleration is v2 minus v1 over t2 minus t1. So acceleration represents the rate at which the velocity is changing. Sometimes it could be increasing, it could actually be decreasing also. So you could have 20 miles per second velocity at time t1 and then 10 miles per second velocity at t2, and that is also acceleration. We normally refer to it as deceleration. So now that we understand speed, velocity, and acceleration, let's talk about the last parameter, which is mass. Mass represents the resistance of a body to be accelerated. So if you imagine an object here and let's say another object which is big, usually that represents a higher mass, but not necessarily. But in this example, let's assume this is mass m1 and this is mass m2, and m2 is greater than m1. What we mean by that is it's more difficult to accelerate this object than it's more difficult to accelerate this the second object than the first one, because it has a higher mass. So the more appropriate way of thinking about mass is a measure of body's resistance to acceleration. So when you have higher mass, you have more resistance to acceleration.